I'm gonna be famous.
Probably so.
Just like shout in the middle of the video.
Right now. So we're planning to plot some polar coordinates. So every polar coordinate has two parts. The first part is the radius, or the distance away from the origin, and the second part is the angle that we're going to go that far away from the origin. So every polar point is an r comma theta, an angle and a radius, and this is what a polar graph looks like. Okay, where the center is, of course, the pole, and we have like the positive x over here and the positive y up there, but we change them to have radians, or rather, angles as we go around, and then each one of these rings is the distance away from 0. Okay, so from the center towards the outside is always your positive distance, and we'll talk about negatives in a second. So we're going to plot these points on here so that we can learn how hopefully to do this. So our first one is 6 comma 7 pi over 6. So we're going to go around our unit circle. And so we find 7 pi over 6, which is right here. And then we're going to follow this line back till we get to the origin. And we come out 1, 2, 3, 4, 5, 6. So this spot right there. Oh, where'd it go? 1, 2, 3, 4, 5, 6. This spot right here is where we should put the letter A that represents the point 6 comma 7 pi over 6. Okay, it is 1, 2, 3, 4, 5, 6 units away from the origin along the 7 pi over 6 line. So let's do that with the rest of these two. We have 3 negative 3/4 pi. So first we're going to go negative 3 pi over 4. So negatives come down this way. So here's negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4 is right here. So also known as 5 pi over 4. And we're going to come 3 units away from the origin. 1, 2, 3 units away. And this is where we're going to put the letter B. At 3 units away from the origin along the negative 3 pi over 4 line. So let's see, 8 comma pi. That shouldn't be too difficult, as long as we can count our letters right. I know there's 10 of them, so this must be 8. There are 10 rings to here. So that is 8. So this is where the point C goes, at 8 comma pi. And now we have this strange one, negative 6. Negative 6 and 5 pi over 3. So we come over here to the 5 pi over 3 measurement. And positive values, positive radii, come from the origin out towards the outside. So this would be positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, coming towards this. So if I have a negative radius, that means I'm going to go away from that 5 pi over 3 line. So it says negative 6, so I'm going to come away from the negative 5 pi over 3. 1, 2, 3, 4, 5, 6. So this is where I'm going to find negative 6 comma 5 pi over 3. Away from where it's supposed to go. So positives come towards the outside, negatives go the opposite direction. So this is point D at negative 6, 5 pi over 3. Okay, also the same as it looks like 6 comma 2 pi over 3. These 2 points are in the exact same spot. So the next one is negative 11 pi over 6 and negative 5. So 11 pi over 6 is almost all the way around your circle. I believe it's here. Okay, this is also known as negative 11 pi over 6. And the radius is negative 5. So I'm going to go 5 units away from this line. So here's your 11 pi over 6, 1, 2, 3, 4, 5. This would be 5 right here. That's negative 5, comma, negative 11 pi over 6. So this is point E. That's an E. And the last one, F, negative 4, negative 2 pi over 3. So this is negative 2 pi over 3 right here. Okay, this is negative 1 pi over 3 and negative 2 pi over 3. So I'm going to go 4 units in the opposite direction from this one. So I follow this angle line back through the origin. 1, 2, 3, 4. And this is where point F should go. Okay, so it's kind of tricky when we have negative angles and negative radii. Just remember the negatives go away from the outside. Okay, they go in the opposite direction of. And you'll do fine.